Okay, so let's say that you're stuck with a particular sample size based on resource constraints as your justification. Either you have to collect data over a particular period of time, or you're limited in your ability to sample from the population that's desired. There are a number of things that you should consider when you're conducting a study based on resource constraints as the justification for your sample size. Now, for dissertation projects, obviously the primary aim of conducting the dissertation is pedagogic. The idea is that you learn about the process of proposing and conducting a research project. And so it's not really an issue that resource constraints mean that you won't be able to get the sample size that might allow you to estimate effects with a given level of precision or detect effects that you've a priori decided are important and worthwhile being able to detect. The idea is that you just demonstrate the learning outcomes, that you understand some of these facts, and also the limitations of a resource-constrained justification for a study's sample size. But there are a number of studies that are published within the literature, and the vast majority, in fact, are constrained by resources in terms of their sample size that they manage to achieve. If you're a researcher trying to plan a study, you should think about the costs and benefits of doing a study when you can't necessarily achieve a sample size that will allow for precise estimates or for good power when it comes to hypothesis testing. So let's go through a couple of considerations that Larkin suggests in terms of whether or not it's worth doing a study that might be quite small because it's based on resource constraints as a justification for the sample size. So, to start off with, you can think about whether or not there's the possibility a future meta-analysis could be conducted. Small samples in and of themselves don't really tell you a lot when it comes to trying to interpret the findings of your study, but if it's a question where there may be a number of studies being conducted, some of which, or all of which, are constrained by resources just because of the nature of trying to conduct that kind of study, then maybe you should consider whether or not it's a question that could be amenable to a meta-analysis being performed in the future of all of those smaller resource-constrained studies. If that's likely, then your study could still, even though not in isolation, contribute to answering the questions of interest, but as part of a meta-analysis it could do. Some researchers, even when they find that they're constrained in the studies that they can conduct themselves, conduct a series of smaller studies and perform their own what's called internal meta-analysis. We've done this with studies in the past, where we've adapted the experimental protocol ever so slightly, and because it's difficult to sample participants and recruit participants to take part in studies, we've often conducted a series of smaller studies that we then meta-analyse. We should also think about whether or not the study is being done because we want to try and make some decision as a result of the data that we've collected. So whether we want to decide whether to claim that there is an effect of a particular intervention, for example, or whether there is a relationship between two variables, or whether there is a difference between two groups or conditions. And particularly if we want this decision to inform maybe practical decisions that we might make in an applied setting. Because with typical frequentist statistics, we're often trying to control our errors, and even when we're trying to make claims in Bayesian statistics, we still have to consider that we might be wrong or right in making a claim about the presence of effects or the magnitude of effects and so on. Then it's worth considering whether or not we should conduct something called a compromise power analysis. So if, for example, we find that we can only achieve a certain sample size based on resource constraints, but that there is a particular effect that we are interested in determining, or there's a particular precision that we're interested in obtaining, we can then conduct what's called a compromise power analysis and try to balance out what the type 1 and type 2 error rates are that would allow us to, with that sample size, be able to detect that effect or achieve a particular level of precision. We can then think about the costs of those errors, how high the type 1 and type 2 errors are likely to be, and whether or not it's worth conducting the study and making claims based upon those level of errors. Another consideration is to think about, given the sample size that you can achieve based on your resource constraints and the power or the alpha that you're interested in, so the type 1 and type 2 error rates that you're happy to abide by, what is the critical effect size that you could detect given that sample size and given those type 1 and type 2 error rates that you're happy with? You can think about then whether or not that critical effect size that could be detected given the sample size and the type 1 and type 2 error rates that you're happy with, whether or not that is actually within line with these kinds of sample sizes that you might expect or that you think might actually be important. If it turns out that the effect sizes that you could detect are only very large effects, then instead you should perhaps consider not basing the interpretation of your data on the p-values that are calculated from the statistical tests that you conduct, and not making any kinds of dichotomous claims about the absence or presence of a particular effect. In this case, you might instead then consider the width of the confidence interval around the estimate for the effect that you're making. So, even though you've got a relatively small sample size, your best estimate of what the magnitude of the effect is from an estimation and descriptive based perspective is the mean estimate that you've made. But you get a confidence interval, or a credible interval if you're conducting a Bayesian analysis, around that estimate, which gives you some idea of the uncertainty of that estimate. You can then think about what kinds of effects outside of that range would be rejected as a result of if you were to, for example, consider a null hypothesis as being true, and what you would want to be able to reject given the power of the test that you have. And you can then think about whether or not you're actually able to learn much from the study that you're doing. If, for example, you calculate what kinds of confidence intervals you might be able to obtain for a particular estimate given a particular sample size, and you find that they're very, very wide, then you might consider that you can't actually learn a lot from the study that you're conducting. Lastly, you can think about what is called a sensitivity power analysis. So, again, given the sample size that you're able to obtain given your resource constraints, and also considering the type 1 errors that you're happy to maintain, you can plot across a range of different power levels, so that is considering the type 2 errors you're happy with, and a range of different effect sizes, what could be detected, or what magnitude of effects could be detected at particular levels of power, and then consider what your study actually has the power to detect in terms of effect sizes. So you can consider how valuable your study might be from that perspective. So these are all useful things to consider, particularly for yourselves, because obviously for most of you, your dissertation project, when you actually come to do it, will be constrained in terms of the sample size you can achieve based upon resources. That is the time you have available, the fact that it is an undergraduate dissertation project, you don't have a grant and lots of money to be able to help you conduct this research, and that you have to do it obviously with limited resources available to you. So you're not going to get a huge sample size. Most of you are not going to achieve a sample size that you might initially propose given a particular hypothesis you want to test, or a particular precision for an estimate that you're interested in. But it's worth thinking about these kinds of considerations, because when you write up your projects, you can then factor these in and talk about and interpret your results adequately based upon the sample size you were able to achieve.